This lesson is about simplifying rational expressions. So what the heck is a rational expression? It's an expression that can be written in the form p over q, where p and q are polynomials, and q can't be equal to 0. So for this one, we're going to evaluate the rational expression at the specified value. So here we go. We're going to stick in 3 everywhere we see an x. And we're going to do the nutshell thing again, you guys, because I think it's super important that you can place your numbers where you're supposed to. And now we're going to think about order of operations. We're going to do the exponents first on top. And this long fraction bar means that the parentheses are actually implied. They want you to do everything in the top, everything in the bottom, and then divide. So it's going to be 6 over 5. And yes, you can change that to a mixed number, but you can leave it like this and move on. Let's do another one. This time I'm putting in -1 for x. So again, I'm going to do my nutshell thing. And stick in -1. I got a little ahead of myself. Everywhere I see a nutshell. -1 squared is just +1 because -1 times -1 is a +1. Negative times the negative will give me a +4 plus another 4 on the end. -1 plus 2, well, that's just 1. So I get 9 over 1, and we don't ever want to leave it as 9 over 1. We're going to write it as 9. Cool? Now, let's do another one. Again, I'm going to put in my little nutshells. And I'm popping in -2 everywhere I see a y. And I almost forgot my squared there, so got to be careful. So now I'm going to do my exponents first. And cool. Now some people can do multiple steps at once, and that's just fine. -2 times -2, give me a +4. 16 times 4 is 64. So this would be 8, take away 1 will be 7. 64, take away 25 is 39. And we're just going to leave it like that. That's the evaluation. Now, let's work on the second concept of this lesson. A rational expression is undefined for values that make the denominator equal to 0. So what we're going to do is all we need to do is look at the denominator, see what x value makes it 0, and write the expression will be undefined when x is equal to whatever. But I'm going to express it 2 ways. Okay, here we go. Let's take a look at number 2a. X plus 2. I don't even need to look at the top. I can say x plus 2 is equal to 0 when x equals -2. So we can state this 2 ways. Way number 1. The expression is undefined when x equals -2. That's way 1. Way 2, we can say the expression is defined for all x where x is not equal to -2. So we can say when it's undefined, or we can reverse that and say that the expression is defined for all x where x is not -2. So let's look at the next one. Yeah, let's. I'm going to do this one in blue. So we get 3x squared, and all we have to do is figure out where the denominator is 0. Now, why do we have to do that? Well, because we can't divide by 0. So we need to get rid of all the x's that make that denominator equal to 0. So that's what we're doing. Now this goes back to solving quadratic equations, but the cool thing is I'm just going to divide everything through by 3. Can I do that? Sure. X squared, take away x, take away 6 is equal to 0. This is factorable, x and x, and then we need it to add up. We know since the second sign is negative, the signs are opposite, and there we go. So x is equal to -2, x equals 3. So these are our problem children. These are your problems. So we can say the expression is undefined when x equals -2 or x equals 3. And then, or we can say the expression is defined for all x where x is not equal to -2 and x is not equal to 3. Okay? So there we go. Now this and here might be an or. Let's do a little eraser here and do an or. There we go. Okay, we have a couple more to do to figure out where the expression is not defined. So we're going to take this denominator here and set it equal to, yep, you guessed it, 0. This is also factorable. 16y squared breaks down into 4y. There's no middle term. I have to have opposite signs. Cool? And I'm going to solve each of these. Remember this? Yeah, the beauty of it is it keeps coming up so that you can refine your skills. So y equals -5/4. And the other guy, I'm sure you're going to get this fairly easily. Y equals +5/4. So the expression is undefined when y equals -5/4 or when y equals 5/4. Perfect? And I won't state the second one, but we're good. Now let's take a look at d, you guys. 2y minus 1 over 7. The denominator is always 7, so the denominator is perfect. It's never 0. So we say the expression is defined for all real y in this case. Y, because this is a y, so we want to make sure that we don't mess up on that. So now let's move on. Now we're going to simplify these things. And basically what we're going to do is we're going to be dividing out the ones. Like sometimes you'll have 5/5. Well, that's a 1, so I don't need it anymore. So the other thing that we want to ensure is that there's just like a few cute, adorable things that's the extra here. So the extra says that a minus b over b minus a is equal to -1, and I'm going to show you that a little bit more clearly later on. So let's take a look at this first one. First, we're going to completely factor the numerator and the denominator. We're just going to use our factoring skills that we already have and just do it. So for the top, the numerator, I'm going to factor out a -5, and I'm left with x plus y. And the denominator is also x plus y. X plus y, x plus y are a package deal. So that means I can divide them out and they become the number 1. -5 times 1 is -5, and now we're all simplified. Da-da! Now let's do b. Yeah, let's. Well, the numerator cannot be factored any further, but the denominator I can pull out a common z. So I'm left with z plus 2. And what do you know? These two z's divide out. But what do I get in that z's place? Well, I get a 1, you guys. Don't forget that when you divide out, you're getting 1 over 1 or 1. So the simplified solution to this is 1 over z plus 2. And just to give you a heads up, you guys, this is an expression. Okay, I'm not solving for z. I'm just getting a nice, cute, simplified form so I can move on and do whatever I need to do with it. Okay, let's take a look at this gooba haba. All right, they get more complicated, and the beauty of it is you can have like 20 billion factoring problems in one problem, which I don't know whether you think that's beautiful or not. See how this is a cutie pie negative y squared? Well, for this one, I'm going to factor out a -1. And when I do that, the 64 becomes a -64. And the y squared, negative y squared, becomes a positive y squared. Good? I'm going to keep going with the numerator right now. And now I'm going to rewrite that sucker as y squared minus 64 instead. And I'm going to leave it like that for just a few minutes. Now let's start on the denominator. I'm going to pull out a regular y. So I'm left with y squared plus 12y plus 32. So I'm doing awesome so far. I'm going to leave that y in front, and now I'm going to factor that denominator. The second sign is positive, so I know that the signs have to be the same, and they both have to be positive. So it's y, factors of 32, and I need to get 12, so 8 and 4. So we're doing awesome. We still need to break down that numerator a little bit further. I'm going to copy the denominator down really super nice. And now when I factor the numerator, I'll get y 8 and y minus 8. Good? Because it says sum and difference of squares. Difference between two squares, and I factor it as a sum and difference. So what can go? Well, the package deal of y plus 8 can go, and everything else stays. So -1 times y minus 8 over y times y plus 4. You're done. Don't go and multiply everything out. Just leave it in little chunky monkey things and move on. You're less likely to make an error that way. Now let's do the next one. Yeah, let's. Here we go. We're going to factor. Unfortunately, for both the top and the bottom, there's no common factors I can pull out. But keep in mind, you guys, that these problems are very rigged, all right? And they're totally rigged. So if you're getting a common factor and you get the factors of the numerator, chances are you're going to see one of those factors in the denominator. So let's take a look. Let's do 2x and 2x. Since the second sign is positive, I know the signs are the same, and they're both what? Negative. And the only factors of 1 I have to work with are 1 and 1. And that's it. And I check my cradle, right? The inner cradle is a -2. The outer cradle is a -2. It adds to -4x. The inner cradle, let me restate that. The inner cradle is a -2x. Outer cradle is a -2x. middle will be negative 4x. So I'm all good. So now the cool thing is I'm going to factor this denominator, and let's take a look. How am I going to break down 2x squared? Using the guess and check method, I get 2x, 2x. But chances are that the 2x minus 1 is going to appear in the denominator. That's the chances are. And then I have a negative 5 on the end. That means my signs have to be opposite. And the only factors of 5 are 5 and 1. So I'm going to stick a 5 here. If I do my cradle, negative 1x, positive 10x, bazinga, I get 9x. Me and Sheldon, right? So now I'm going to cross off these because they divide out and get what number, everybody? 1. Very good. So we get 2x, take away 1, over x plus 5. When in doubt, do not cancel out. These guys are package deals, all right? They are, look at how different they look, okay? Next, we're going to do a few more. Let's take a look at E. Well, there's nothing you can factor out on this one. They're completely different package deals. So this one is already simplified. What about something like, this is my extra. What about something like x plus y over x plus y? What about that? Well, they're exactly the same. So they will divide out and get what number? What number? The number 1. But what about this one? One more extra here. If I have x minus y over y minus x. Well, let's take a look. I'm going to do a fancy trick here. In the denominator, I'm going to factor out a negative 1. That will give me negative y plus x. Good? And look at how cute this is. I could write this as a x take away y. Beautiful. Now I have a common factor. So I get 1 over negative 1, which is negative 1. Neato Guido. So if the signs are the subtraction between those two things and the variables or the terms are just switched around, I could bazinga in and get negative 1. Now let's do the next one. Yeah, let's. And it looks daunting, but since that there's 4 of these guys on the top, I'm going to try factoring by grouping. Remember that way back when? Let's look at the red one. I'm going to pull an x out, and I get y plus z. Good? Now let's look at the black one. I'm going to pull a y out, and I get y plus z. Perfect. So now, again, I'm not quite done with my factoring. I'm going to pull a y plus z out in front, and I'm left with the x right here and plus y. Good? So see what I told you about the problems being totally rigged? They want you to divide this guy out. Get a 1 here, x plus y. Done. There we go. All right, let's take a look at this one. This one's awesome because the numerator is going to factor. I know they're different signs. What do you think? You think one of them will be x minus 5 and the other one will be x plus 9? If you do your cradle, you bet your sweet bippy. So we're going to get 4x in the middle. Yay! And x minus 5. This problem is, yeah, you guessed it, it's rigged. So divide out those x minus 5s, and I just get x plus 9. Yes, it's over 1. But if there's a 1 in the denominator, you can just write your numerator down. Now you're able to do the assignment associated with this lesson. Go for it. Factor, factor, factor.